Hi everyone and welcome to another wonderful Sam Labs webinar. My name is James and today I'm going to be running through a very cool session with you guys to help you understand how and where you can use Sam Labs in your classrooms. So over the course of this session, I'll be using the Alpha Kit to show you just how easy and fun it is for students and teachers alike to design, write, and debug their programs with the use of our SamSpace app. So the Alpha Kit is one of the brand new kits that we have released quite recently. Behind me, you'll see we have our Team Kit and our Classroom Kit as well, which are the other two new ones. When I open up inside, we can check out everything that is available. So you'll see that there's a link here to download the app. It's a free to download app that you can use across platforms. Inside the kit, we've got our SAM blocks, like our motors, our light sensor, our light, and some really cool accessories as well. With these accessories, you can create things like cars, robots, and a ton of other projects. Getting the blocks is only the first step. So the lesson that we're going to go over today is something that I created especially for you guys. And this is something that we are calling the Home Alone code. It's based off of the classic film Home Alone. And it's a way of using our SAM blocks and the code to make it appear as if your home is inhabited when people are going away on holiday, or if the house is empty and you're there alone. So we need to consider first the problem that arises when nobody is there. If it's dark and if a house looks as if nobody is there, it's more likely to be targeted. Burglars could be walking down the street, see a completely empty house and think that's the right place to go. So we're going to try and come up with a solution to that. We're going to create a code, starting initially with a cool design side of things, which you can use in your classes, and then moving on to the more hardcore coding elements. We also have to try and link what we think is a solution and how Sam Labs can affect that. So first of all, when we think about how our house looks when people are there, we need to highlight different areas. So if there's noise perhaps, if lights are being used, if it looks as if the lights are being turned on and off regularly, then it definitely looks as if somebody is home. You can hear through the windows or through the doors that there are voices coming from inside, as well as movement. If you've got somebody moving around and you can see that the shadow or the silhouette is by the window and standing out, that's probably a lot more likely to deter someone from coming into your house. After we highlight those kind of things and we think about where we want this code to work, specifically around nighttime, I feel a lot safer during the day than I do during the night. So maybe if there's a way that we can create a code that is activated only in the darkness, that would be really, really fun. So after I've highlighted these kind of areas, we can go into our kit and we can see what parts here will link back to a solution of this problem that we've highlighted. So the first thing that comes to my eye is the light sensor. This can be used as an input to power our code. So if I wanted to have the light sensor react whenever it got to a certain low level of light, we can do that. So I've got a planning here, my Home Alone code. I've already got my light source, which is my lamp. So I'm going to draw in my light sensor underneath here at the very, very start of my code, sitting there all alone. And now we can start to add things to it. So if I wanted to have this code working, I don't want it to happen all the time. I want it to go and work for around maybe 10 seconds, activating different outputs like my light and my motor. So I'll connect this up to a hold function just here and set this to 10 seconds, just like that. But when I think about my light sensor, if the light sensor is just connected to the hold, it's going to activate the code every single point during the day. So I want to try and find a way of filtering the amount of light that comes through my light sensor and how it's going to change my code. So luckily on the SamSpace app, we have a function called the filter, and that will let me limit the amount of times the code is activated. So if instead of from 0 to 100, if I say that if the amount of light is around 0 to 20, we can then connect these lines up, just like so. So now as soon as my light sensor reaches 20, I want that code to activate. After we thought about this, we can talk about the outputs that are going to be there. So my light could be used and placed inside a room upstairs so that if the light gets too low, it can start to look as if someone's turning on light switches. So if I connect this up to my hold, I'll add my lights in here. There we go. So we have our output. We've got one output already, which is going to start solving our problem. The motor would be a really, really cool way of creating some motion. So if I attach a sort of silhouette, just like this one here that we've already created, it's going to look as if my mum is already standing in the window waving to someone and stops two people from coming into the house. So this would be a really, really fun way of creating some code as well. So not only do I have my light, I've also got my motor. So these are ready to be paired up. But if I have them turned on for a whole 10 seconds, it's going to look very fake. So I'm going to try and add in a bit of time here. Using the interval block would be a really cool way of making sure that it goes a lot more regularly instead of being constantly on. So if I set my interval here to around 1 second for each of them, there we go. This is starting to look a lot better. This means that the lights will flash every 1 second and the motor will spin every 1 second. I think this will give it a lot more of a realistic feel using the code. The last two things I want to do is when I look at my light, I know that it's going to turn on white. But I think if it was a different color, for example, my color, my favorite color is purple. So if the light was purple, it might look as if there's some kind of party. So I'm going to connect this up here right at the start of the code so that as soon as the code is activated, everything after it will turn to the purple color. And I also want there to be a bit of noise, a bit of sound. So where I've got my light, I've also got my interval. I'm going to put in one of our software blocks, which is the sound player. So now as soon as this light is activated by this interval, the sound player will also be activated. And that means that we'll hear somebody speaking as well whenever the light reaches below 20. So I've designed this now, and it's really important I have this on hand when I go into actually writing the code. So I'm going to share my screen with you guys now, and you're going to have access to everything that I see on the app. So give me 2 seconds just while I set that up. Here we go. So I've already got all of my blocks paired up. They're here and they're good to go. So just as we saw, and you'll be able to see as well, on the plan that we created, the first thing we need to do is get our light sensor onto this canvas. So I'm going to drag it on. You'll immediately start to see that it's picking up that value of light. It's gone onto our canvas. So whenever I cover it over, we'll be able to recreate that instant darkness feeling. So this is going to be our input. It's going to power all of our code. As we've seen in the code that we created, we want to then add in a filter block, which means that it is going to only allow the values between 0 and 20 are coming through and activating this code. So I go into the toolbar here, take out the filter, which is part of the number section, and connect these up, just like this. If I double click on the filter, this will allow me to change it. And this is where the true personalization comes into the coding. So I take the first one down to 0, and the second one will go down to around 20. There we go. Perfect. The next thing that I want to do is I want to add in my hold function. So as we discussed before, if I didn't have my hold function, as soon as the light goes below 20, it's going to constantly keep on turning on those lights and those motors, and that isn't going to look realistic. So if I go to the timing functions here and take my hold, I'll connect it up to the filter. And just as we edited the filter, I'm going to edit my hold. It's already set to 1 second. I'm going to add in another 0. And what this means is that everything that I put after my hold here is going to be active for a total of 10 seconds. It's already looking good. The next thing that I've added in the start of my code is that I want it to change color. So we have a whole lot of functions in the toolbar. Some of them are specific to certain blocks. So the color here is specific to the RGB LED. I've already shared my favorite color is purple. So if I double click, the settings here will allow me to take it around here. For children as well, to be able to change something like the color and to make it a lot more personal to what they enjoy and what they understand, it makes it so much easier for them to pick up the coding. Brilliant, this is looking good. My next task, if I go back to the design that I've done, is to add in my interval blocks. So that's going to give those pulses of time whenever the light and the motor is active. These are found back in the timing. The timing section is probably my favorite part of SAM being able to have things happen, not constantly, but every now and then makes it seem a lot more realistic to the coding that we see in everyday life. Things like traffic lights and light switches, it is much better for them to be done on time basis. So I need my 2 lines. One of them is going to be connected to my light. And we'll do that to this on here. And the last one's going to be connected to my motor. Just like this. So you can already hear that my code is starting to work without me even having to change anything. So I'm glad that everything's working in place. In a second, we're going to test it and see just how much it is linking up to our original plan. So the final part of the code that we had decided to do is to add in a sound player. So I want it to seem as if someone is speaking when we do our code. So the code that I'll choose here is the voice. I'll go for this one here. Okay, this looks just like the code that we've already created. So I'm going to give it one more test, and I'll show the blocks for you guys as well to see how it works. So here we go. My motor's running, my light's turning on, we've got a bit of movement, but it isn't working as I had originally intended. I wanted the filter to work whenever it went below 20, but at the minute it's letting the value through regardless. So I think the first thing I want to do is get rid of this filter. If I go for a block such as the compare, it means that I'll be able to specify the exact number when I want this code to activate. Outside, we've got streetlights in my home, so I know that the code is normally active when it gets to about 10. Where it is equals, I can change this a bit more to say that I want it to be less than. So if it goes to either 10 or less than 10, it's going to activate my code then instead. Also, with my light, it's still turning onto a white color. I wanted it to turn pink, and I think when I look at the code now, I can see that the color here isn't linked to the light as I wanted it to be. Instead, it's linked to the hold function, so it's not going to have any change at all. So I'm going to get rid of this here instead, and I'm going to connect it up to my light more directly, just like that. I can separate my code a bit more to make it a bit more obvious. So now whenever I want the code to activate, I think it should change that a bit better. I'm also thinking that the motor being able to run every 1 second is probably not realistic enough. So I'm going to set this to 2 seconds instead to make it look as if someone's moving around a lot more active. So we're going to give it one more test. I'll show my blocks again. So as soon as the light sensor goes below 10, it's going to activate my code and show all the movement, sounds, and noises that we want it to. So let's give it a try.
All I ever want. All I ever want. All I ever want. All I ever want.
So once again, we've come up with one more problem, and this is the whole process that is known as debugging. It's about finding the problem, seeing what happens, noticing those patterns, and saying, although it may be working in the way that we've created it, it's not doing as we wanted it to do. So my sound player is playing a sound, but when it's connected to this interval here, it's making the sound play every 1 second, and that isn't getting the whole sentence out and across to them. So I'm going to get rid of this line here and connect it instead directly to my hold. And what that should do instead is make the sound play whenever the hold is activated, and then after the 10 seconds is up, it won't play again. So one more time, let's do one final test.
All I ever wanted in life was to shine.
Perfect. Now my motor is running a lot more smoothly. My light is turning pink as I planned it. When we get that whole voice clip out, sounds exactly like something my sister will say. So people are going to think that I'm not just home alone. I've got people who are there with me. So the design element, the debugging element, the writing element, these are all core principles within coding. And regardless of the country that you're in, this is something that every child can do, enjoy, and be part of. I'm going to go back on my original screen now with you guys. So I can go into talking a lot more about the content that we create and how this links. This lesson plan was created especially for you guys. It's not something that we have available on our website. But if you go onto our website, you can find a lot of projects to do and to complete within the lesson plans that we have, as well as the tab that we have there called projects. The way that the lesson plans are created is aligned to the coding curriculums. You can get step-by-step guides with visuals that help out the teachers to see how they can use this in their classrooms. We have student guides as well, which don't have as much information on them, but instead have blank spaces where they can write down their thoughts, their answers to questions, and as well the code that they create, so they can come back to it for reference. At the end of every student guide, we have a chance for them to reflect on the lesson that they've done and to show you how they think they're doing, and it's an opportunity to provide a formative assessment for the work that they do. As well as these projects, we really want those really creative people to come up with ideas and thoughts and let us know so that we can take these and give you guys some credit. I know that everyone watching is one of those creative individuals, so it's not going to take much to come up with those thoughts and ideas that we can use as well. The one last thing that I'm going to show you guys before I go is the content that we have on our website. The website itself is very easy to navigate, and you have access here. The app that we have, if you go on to Getting Started, you can download this app and it is usable across platforms. So regardless of if you're using this on a tablet, on a MacBook, or on a Windows computer, you can download it and check it out and use it. At the top here, if we go into teaching materials, this is where we store all of our lesson plans that you have access to. They're downloadable PDFs, and if you download the zip file, you get both the student and the teacher guide, so you can see how they relate together. And the last thing that is really, really cool for you guys to check out is our teacher's guide. So this is in-depth understanding about what the blocks do, how they work, and how you can use them in your classrooms. That is all we've got time for today, unfortunately. I hope you guys have had a chance to see how we can use SamLabs and see how you can use it in your classrooms. As I mentioned before, there is so much that you can achieve just by using one kit like the Alpha Kit. I know there are a lot of teachers who are very conscious about their budget. So the Alpha Kit works as an incredible starter pack to test with your students before you consider getting into the larger kits. So I would definitely suggest testing that out and trying it in your classrooms. If you have got any questions and you want to get in contact with us, you can send any email to info@samlabs.com or get in contact with your regional SAMster so that they can provide you with a bit more information. We're always eager to see what teachers are doing and how they're using SamLabs, and if you've got ideas, we can always help those ideas blossom with you. I look forward to speaking to you guys again and helping you guys to design, write, and debug your programs. We are on hand to provide the support whenever you need us. I'll be checking out the info email account every single day to see if there are anything that I can do to help you guys. Until then, keep on coding, and we will be back with you very shortly with another webinar. Thank you guys very much. Bye.